Hi, this is Andrea Kane, and I'm here with you for HIT 452. We are now on week 8, and we are looking at chapters 10 and 11 in our textbook this week. This lecture video will be on chapter 10. There will be a second one that will be on chapter 11. If you're looking at your syllabus, you'll see that this week we will be covering unit objectives 9.10.1 and 9.10.2. as well as 9.11.1 through 9.11.7. Okay, so if you want to follow along, I am in the textbook on page 169. Let's talk about descriptive statistics in healthcare. Our learning objectives according to the book are to explain how and why percentiles are used, compute the percentile from an ungrouped distribution, prepare statistics measuring central tendencies such as mean, median, or mode, and prepare statistics measuring variation such as range, variance, standard deviation, and correlation. Please make sure that you are familiar with central tendency, and you understand the meanings of mean, median, and mode, and that you understand variation, and you know exactly what it's meant by range, variance, standard deviation, and correlation. That will be critical to you for this week. Descriptive statistics are used to explain data in ways that are manageable and easily understood. So let's start off by taking a look at variable. A variable is a characteristic that can have different values. So the example they give us here is that someone may be HIV negative or positive. The variable is the status. The values are negative and positive. Another example would be third-party payers include numerous insurance companies. The variable is third-party payer. The values are all the different insurance companies that pay for services. Frequency distribution. This shows the values that a variable can take and the number of observations associated with each value. Do you see now why you need to know what a variable is and what values are? So a frequency distribution shows the values that a variable can take and the number of observations associated with each value. A variable is a characteristic or property that may take on different values. Rank. This denotes a value's position in a group relative to other values organized in order of magnitude. So a value of 50 means that the value is the 50th from the beginning or end of a series. The position of the observation is more important than the number associated with it. Quartile. This is data that's arranged in 4 equal parts. The first quartile includes the first 25% of the data. The second quartile includes the first 25% of the data and the second 25% of the data. The third quartile extends to 75% of the data, and then obviously the whole item would be 4 quartiles, which would be 100% of the data. Decile is just like quartile, except instead of it being 4 equal parts, a decile is 10 equal parts. So instead of it looking at 25, 50, and 75, you're looking at 10, 20, 30, 40, 50, 60, 70, 80, 90, and that sort of thing. Percentile separates scores into 100 equal parts. So a score at the 54th percentile means that the score is greater than or equal to 54% of the scores in the group. This is called a percentile rank or percentile ranking. Again, all this comes down to definitions. So this week, you're going to be studying definitions for a big part of this because you won't be able to run the numbers without those definitions. So read through your book, look at those royal blue words that are that are in that royal blue color in your book. Make sure you know those definitions. If you aren't sure what they are in the chapter, I believe there's a glossary in the back of your book here. Yes, there is a glossary in the back. It's Appendix D. Make sure that you take a look at that because you need these definitions. All right, measures of central tendency. If you're following along in the book, we have now moved on to page 176. In summarizing data, it's often useful to have a single typical number that is representative of the entire collection of data or the specific population. These numbers are customarily referred to as measures of central tendency. 3 measures of central tendency are frequently used: mean, median, and mode. So you need to know what mean, median, and mode are. And your book does a great job of walking you through this and giving you examples and showing you how to calculate these. So make sure that you are going through here and following the examples and doing the exercises so that you can see those. If you don't have answers to the exercises, you can shoot me an email and I can get you those answers. But I believe in the back of your book, all the odd numbered chapter exercises, you can get those answers in Appendix E. So when you do the chapter exercises this week, all the odd number ones, their answers are in the back of the book in Appendix E. If you need the answers to any of the even numbered chapter exercises, shoot me an email and I can get those for you. So again, coming back to here, the 3 measures of central tendency that are most frequently used are mean, median, and mode. You need to know what mean is versus what median is versus what mode is and how to calculate those, and your book will walk you through those. But here's a slide on mean. It is the arithmetic average. It's common to use the term average to equal mean. So in your head, mean should equal average. To obtain the mean, you add up all the values in the distribution and then divide by the total number of values in the distribution. So this gives you an example here, how you would do that. So you add up all the values and then you divide them by the total number of values that are involved. Mean is the most common measure of central tendency. It's easy to compute, but it is sensitive to extreme values, also known as outliers, that can distort its representation of the typical value of a set of numbers. Because think about this. If you have numbers that are mostly between 10 and 20, and then you have 3 numbers that are in the 80s, what is that going to do to your average or your mean? It's going to skew it because of those outliers. So that's one of the reasons why mean is best to be used when you have values that are close together. Median is the midpoint or center of the distribution of values. So it's trying to give you the middle of the data, literally. The median value is obtained by arranging the numerical observations in ascending or descending order and then determining the value in the middle of the array. To arrive at the median in an even number distribution, add the 2 middle values together and divide by 2. That's a quick, easy way to do it. The advantage of using the median as a measure of central tendency is that it is unaffected by extreme values. So you can see here, where you want to use numbers that are all together for mean or average, if you have those outliers, it's better to do the median to find the middle. Because as we know, with mean and average, those outliers skew that number. All right, mode. Mode is the value that occurs with highest frequency. It is the most typical. It is the simplest of the measures of central tendency because it does not require any calculations. Isn't that great? In the case of a small number of values, each value may occur only once, and there will be no mode. The mode is rarely used as a sole descriptive measure of central tendency because it may not be unique. There may be two or more modes. And then when that happens, they're called bimodal or multimodal distributions. So how do you choose a measure of central tendency? It depends on the number of values and how they're distributed. It is possible for mean, median, and mode to be identical. The mean is preferable because it includes information from all observations. If the series of values contains a few that are unusually high or low, then you want to use the median. The mode is often used in samples where the most typical value is preferred. Interestingly enough, the mode does not have to be numerical. Moving on to variability. Okay, this is it starts at the bottom of page 181, but moves on to page 182. Variability. So now that we've talked about the distribution, we want to talk about how widely the observations are spread around the measure of central tendency. The mean gives a measure of central tendency of a list of numbers, but tells us nothing about the spread of the numbers in the list. So variability refers to the difference between each score and every other score. It gives us information that the central tendency doesn't have or can't give us. So that's why sometimes you'll see when we're handling statistics, we want to do both central tendency and variability. So keep that in mind. Range. The first one we're going to talk about is range, and this is on page 182. It is the simplest measure of spread. It is the difference between the largest and the smallest values that are in that distribution. It is the easiest to compute. It is the simplest order-based measure of spread, but is far from optimal as a measure of variability because as the sample size increases, the range can also increase, and it is very affected by extreme values or those outliers that are different from the other values in the data. Variance. A frequency distribution is the average of standard deviations from the mean, and the variance of a sample is symbolized by a little s with the 2 in the squared point, like it's s squared to the second square root, or s squared. The variance of a distribution is larger when the observations are widely spread. And variance is discussed at the bottom of page 182 into the top of page 183. And again, your book does a great job of going through and showing you examples and how they're calculated. So make sure that you look through those really closely. To calculate the variance, you first determine the mean. Well, what is the mean? It's the average. Once you have that, then the squared deviations of the mean are calculated by subtracting the mean of the frequency distribution from each value in the distribution. And then the difference between those two values is squared. So it's going to walk you through how this works. And this is all on page 183 in your book. Standard deviation starts on page 184 in the middle of the page. This is the square root of the variance. Because standard deviation is the square root of the variance, it can more easily be interpreted as a measure of variation. When it is small, there's less dispersion around the mean. When it is large, there's a greater dispersion around the mean. So again, when you're talking standard deviation, if you make sure that you follow the formula, it will get it for you. And you'll hear a lot when you talk about quality management. We didn't really cover it in our class, but in quality management, a lot of times they will calculate the standard deviation to try and identify if there is a link, the odds of it being linked to something else. So it's going to go on here to talk about standard deviation, that in a normal distribution of data, most of the values in a set are close to the average, and there may be a few values that tend to be one extreme or the other. The standard deviation tells you how closely all the observations are clustered around that mean or that average. When they're closely gathered and the bell curve shape is steep, the standard deviation will be small. When the examples are spread far apart and the bell curve is relatively flat, the standard deviation is larger. So please make sure that you know that, because when you look at a graph and you see the bell curve, one of the first things you want to look at is it steep or flat? If it's steep, you know the standard deviation is going to be small, that most everything is closely gathered by that mean or that average. If the bell curve is pretty flat or pretty long rather than steep, then the standard deviation is longer, the distribution of data is more spread out and not clustered around the mean or the average. Normal distribution means that if the variable on every person in the population were measured, the frequency distribution would display a normal pattern with most of the measurements near the center of the frequency. In a normal distribution, one standard deviation in both directions from the mean contains 68.3% of all values. That's why they want to calculate it, is because in a normal distribution, you're going to get the most, a significant amount of the values, and it'll be meaningful to then make decisions on that data. Two standard deviations in both directions from the mean contains 95.5% of all values, and three standard deviations in both directions from the mean contain 99.7% of all observations. So keep those things in mind. Skew. What does it mean when your data is skewed? Not all distributions are symmetrical or have the usual bell-shaped curve. So what does that mean? It means that they're skewed. Their numbers don't fall in the middle, but rather on one end of the curve. It's the horizontal stretching of a frequency distribution to one side or the other so that one tail is longer than the other. And the direction of the skewness is on the side of the long tail. So if the longer tail is on the right, then the curve is skewed to the right. If the longer tail is on the left, then the curve is skewed to the left. And this, they show you examples of a normal distribution, which was a bell curve, versus different examples of curves skewed to one way or another versus being bimodal or multimodal. This is all on pages 186 and 187 in your book. Moving on to page 188, what is correlation? Correlation measures the extent of a linear relationship between two variables and can be described as strong, moderate, or weak, and positive or negative. A positive relationship between two variables is direct. Negative relationships are inverse. And it goes over all those on pages 188 and 189. So, correlation. If you're trying to see, is there a correlation between the variables, you're going to look at, obviously, the shape, and you're going to look at whether or not there is a direct relationship or an indirect relationship, which would be inverse. And I really like example 10.17 because it walks you through this. So rather than me trying to explain it over these slides, make sure you take a look at example 10.17 on bottom of page 188 into the top of 189, because I think it'll do a really good job of showing you an example of a correlation. Correlation does not necessarily imply causation. Two things can be correlated without one causing the other. So be careful about that. Don't presume that just because there's a correlation that there's causation. That may not be true. Things can be correlated by a totally different cause. And they may be caused by two different things even though they do correlate. So watch out for that. It's going to talk to you about the value for correlation between -1 and +1. If there's a correlation of 0, it means there's no relationship between the variables. If it's -1, obviously it's going to be an inverse relationship. If it's a +1, it's going to be a direct relationship. That they're influencing each other. All right, that's it for chapter 10. I'll be back shortly to talk to you about chapter 11.